typically because they need to have a permanent IP address, right? Okay.
Yep.
And then coming back, when this is first one, then coming back for the peer-to-peer, what do you guys pick?
A and B.
See, if you guys pick the A here, that means client server cannot pick the B, right? A and
B.
B. Okay. So peer-to-peer, a process request service, basically for peer-to-peer. So each user could be client, could be server, right? So for client server is what? Client is asking for service and the server is providing the service. Makes sense? So the functionality very clearly split. Server, which is providing service. Server need to be what? Ready. I need to be on, I need to be ready. So whenever a client, they want some service, I just provide service. So this basic client service is very easy to understand. In that case, why the server need to have a permanent IP address? Typically also have a popular port number. Like everybody know for the web server, HTTP server, the port number is what? 80, right? Because what? The server is ready. The client needs to know where to communicate with the server. That's why the server needs to have a permanent IP address and a popular port number. This way, the client could initiate this action, communicate with server, asking the service. Make sense? Okay. For the peer-to-peer situation, basically the major theme is like in the classroom. If we have a client server, right? If we have a client server, so far we only have 20 students. So, for example, I'm the server. Okay, I'm the server case. Then, if I have a small case, you guys are client, you have anything, I provide the service to you guys, right? Client server. Then sometimes, for example, like we change another university, like the UT or A&M College Station, right? The class is not this size. Make sense? In that case, if you still use the same architecture, the server could be what? Could be overwhelmed, right? Make sense?
Yeah.
Could be. But currently, still things could change. It's like, it used to be like you have your server, you just have a physical computer provide a server. Now the things changes. The server is what? It's used in the data center. When more service needed, it could be elastic. They ask for more resources. That's what's happened in the cloud kind of situation, right? But the thing for the client server, but the server, no matter what, the server is what? It's a bottleneck. Make sense? Agree, right? Although how to solve this bottleneck depends on different technology. But at the same time, client and server is kind of relatively easy, right? If I want some kind of service, if you have questions, if we start learning the network, you have questions, you know where server is, right? You know my name, you know my office, you know my email address, you can ask for it. That's basically the same situation, right? Got it, right? For the peer-to-peer situation, it's different story. It's like the scenario is like everybody helping everybody. Make sense? So basically, for example, we want to download some kind of files. If I already have the piece of the files, I can share with my neighbors, right? Then if I need some other pieces, I ask for the help from other kind of neighbors. Makes sense? Everybody helping everybody. Later on, basically, I ask you the pros and cons for each data, those kind of network architecture, right? Later on, we're using some numerical example to show why in the different scenarios, those could be different. Make sense? Yeah. So for the peer-to-peer, you could be server, you could be client. If you provide service to other people, right? You are providing the kind of server kind of functionality. If you're asking the help from other people, you are like a client. Makes sense, right? Yeah. That's basically think for the P2P is not. Later on, remember those later on we need to actually know why the P2P has a certain kind of advantage, right? Then of course there's no free lunch, right? Eventually, what will be the potential problem or challenges associated with it? Okay, so number three. So many of you ask you because TCP and UDP are two major protocols for the transport layer. This is a quick summary regarding difference of TCP and UDP, right? For the UDP, guys, question number 3, what do you guys pick? Louder. B. So it's the best effort service. What else? Oh, you guys are good, huh? So UDP is the best effort service, okay? Because
I don't guarantee what's sending.
And for question number 4, what do you guys pick?
Everything but A. C. Oh, C. Sorry.
C. What else? D. Who picked the D? Myself. And what else? E as in egg, right? You know we have the egg problem recently, right? That's why I look at E and thought about the egg, joking. What else? So I like the answer. What about everything else? I want to explain a little bit. So why the B and the D doesn't mix is not correct. Okay. So best effort service is not right. So what is best effort service, guys? UDP, of course. What else? Guys, remember layering dependence, right? Transport layer is sitting above which layer? Network layer, right? It's sitting on top of network layer. Network layer is the best effort. Okay? It's best effort. When we talk about IP, always best effort service. We try our best. We cannot guarantee everything. So transport layer is sitting above the network. Okay? Then for transport layer, we have 2 major protocols. One is TCP. The other one is UDP. Based on your current understanding, UDP is what? Which one is simple? TCP and UDP, which one is simple? Intuition. UDP, right? Because UDP didn't provide much, right? TCP is trying to provide something, right? Makes sense? So for the transport layer, TCP and UDP, 2 major protocols. TCP, UDP, we call it one SIM protocol. Makes sense? Very relatively simple protocol. Makes sense? And the TCP, we still trying add lots of stuff. Because for some application, for example, I'm trying to transfer some money to my daughter currently she's in college, right? Should I transfer 500 or 5,000? Indeed, it matters, right? Or 50,000 makes sense. Matters. In that case, so we care about what? Reliability. We care about it. In the video called integrity. Makes sense? So in that case, you remove 1 bit. I cannot tolerate that. You guys remember different service. Last time we mentioned we will watch video. I can care about it. I don't care about the integrity that much. Makes sense? I lost a couple of frames. It's okay. It's a little bit junky. It's okay. It doesn't matter. But some application, they have to be what? Reliable. Your email, remember, your email, even your web browsing, all based on what? TCP. But for lots of video, audio, like I make a phone call, right? We have a Zoom. We could tolerate some loss. Makes sense? For the Zoom, it's proper and not using Zoom. Just video, watching, streaming, make sense? Okay. That's basically for the TCP, they care about the data integrity. Make sense?
Yeah.
That's basically we picked about loss-free data transfer, right? But flow control and congestion control is really, really important topic for network. Okay, that's basically TCP or can provide. Remember those. I do not want to explain too much, but flow control and congestion is really important. But the question is, why we're not picking B and D, right? Yes. Why do we not pick B and D? Not everything else part, guys. Who wants to say? How about the throughput guarantee? Why the throughput guarantee.
不是能guarantee，都是guarantee。
How about the D part, real-time delivery? Because they cannot provide real-time delivery. Like this. The reason is why? Because the internet is what? Packet switching, right?
Yeah.
The foundation is packet switching. So remember, we are doing what? We are using what? Statistical multiplexing. We are playing a probability game. Remember, you guys do the homework. In 99.9, we are okay, but we just cannot use strong word guarantee. Make sense?
Yeah.
That's basically, we cannot guarantee the throughput. In certain very small probability case, very small case, if everybody try to access the internet, it will be congested. We cannot guarantee those.
Yeah.
Make sense? If it's congested, can we guarantee the delay? No, right?
No.
Make sense? Although 99% most of the case we are fine, but we just cannot guarantee part. Got it? So we'll quickly review, then we'll move on to the next section. Okay? I don't know why it's closing for me. I got my second master and PhD back at the Rutgers University. During that time, the wireless network, the lab. So basically, when we chat about all those kind of killer applications, at that time, in my graduate studies, everybody talked about what will be the next killer application. That's the time. Basically, we are looking for after the .com level, we are looking for some. That's basically, I put some of those things. But now, recently, we have plenty of new killer application coming up, right? Because remember, the dependency application depend on the network. But at the same time, network provide those services for the application. So those are some things. At least at that time, those quite a few new applications coming up. With new application, your network things also can change. That's basically, if you check this edition, it's a previous edition of this book. How the network layer is running also different. Okay. Principle. So quickly, if you're fine, we'll quickly passing through. So when we create, this is trying to say the client server kind of architecture. Okay, when you're trying to write an app, actually plenty of stuff is the operating system will do that for you, right? Assign those kind of things. It just seems not that hard. And when you're doing the application, it's all still the end-to-end concept, right? When you're writing an application, actually, do you care about how actually the package passes through? You did it, right? Makes sense? You assume everything will run through. It's kind of end-to-end concept. Everything will depend on the lower layer, and lots of it is handled by the system software. And then possible, like we mentioned, depends on the application structure over the virus system, client server, and the P2P. And for the client server, quickly, the server will be what? Ready first, right?
Yeah.
Ready all the time, right? Just ready, wait. But who initiated this process? Client. You remember those? Basically, server just be ready, but the client initiated the communication because client need those kind of service, then initiate those. Makes sense? That's something I want to pinpoint. So in that case, server, because you want to know because client need to initiate the communication, right? In that case, server need to be what? Need to be known by the client, right? Basically, for example, every time I check my private email, I go to yahoo.com, right? I know the server's IP address and the port number. Makes sense? That's basically basically for the server, they typically have a permanent IP and port number, and we call it popular port number. For the IP address, IP version 4, how many IP version 4 address do we have? What's the IP address? You guys, if you guys ask you guys doing the IP configure, who did? What's your IP address used in your home? Nobody did? It look like 192.168.17.6, right? So for IP address, I'm talking about the version 4. How many IP version 4 address do we have?
4.
IP version 4 address. How many binary bits there? So we typically have 192.168.something, right? Each 192 means what? Each 1 byte. Right? Makes sense? That's called dotted decimal notation. Each number means it's 1 byte of a binary number. You change the corresponding decimal number. Makes sense? In that case, your 1 is a number dot. You have 4 numbers. You have a 4 byte. Your IP version 4. Do an IP configure back at home, okay?
Yes.
So in that case, for your IP version 4 address, how many binary bits? 32, right?
32.
4 bytes. 4 multiply 8.
So
then
4 million.
how many different IP address?
4 million.
2 to the 32.
32, yeah.
4 million, how do you get 4 million? 2 to the
Right.
32, it basically is 2 to the 2 multiply 2 to the 30. 2 to the 30 mostly in the gig part, right?
Yes.
2 to the 30 is gig, 10 to the 9, not a million. Million is too less.
Okay.
Think about the whole world. If we only have 4 million IP address, we have a 4 gig, right?
Yes.
4 multiply roughly, not close. 4 multiply 2 to the 30. That's the IP address. Make sense?
Yes.
In that case, because we mentioned for the server, we have permanent IP address, right? For the IP address wise, we didn't know. Second thing, we need to talk about the port number. We already mentioned the port number, right? Port number belongs to which layer? Transport layer. Then in that case, if I ask you, so you already know HTTP is port number is 80, right? So for the server wise, typically assign a popular port number. Make sense? If you check SMTP, it should be 25. No, FTP is 20 and 21, right? SMTP is 25, right? DNS is 53. Later on, you guys can check. Basically, for some popular service, assign some popular port number for those service, because later everybody can easy to access, right? If you know address, if they're like a big shop, you know it's there, you can go visit. Similar concept. Make sense? But if I ask you, how many port number do we have? That was related to how many bits assigned to that port number. Make sense? Similar to the IP address. IP version 4, we have 32 bits, 4 bytes. For the port number, we have 16 bits. Make sense? If you have 16, if you check, go back, do it very sharp, download some kind of a packet, look at the port number and IP address section, you will see. For the port number, we assign 2 bytes for that port number. Source port, destination port. In that case, we have a 2 to the 16 different port number. Make sense? Because when we check about the port number, when we say we have a permanent IP address, a popular port number, then if you check when you're sending out as a client, you also need to have a port number. If you check the port number the OS sent to you, assigned to you, the number is relatively big. Make sense? Go back, check when you know this part. Then, like I mentioned, we know this IP address, but if we don't know this IP address, what will happen? For example, sometimes we don't know this IP address, right? We only the web name, like some kind of new website is coming up. Of course, we don't know the IP address. Then what kind of service will provide this? But in order to access the corresponding server or corresponding part, you need to know the destination IP address, right? Make sense? For example, even the Google.com, do you know the IP address? No, right? But how did the package got the destination IP address in there? Yes. What's this called? DNS. DNS is helping you, right? destination IP address put in the network layer header. Make sense? So, and point here is for the server, you know some kind of characteristic there, right? If they need to have a relatively permanent IP address, popular port number, make sense? Then in that case, for the client device, for example, you guys are using the computer, right? Ask you what's your current IP address, you know? Or next time, are you using the same IP address? But for next Monday we have class, your computer is still on, right? You're still access internet, right? You need to have an IP address. Do you use the same IP address? No, not necessarily. Maybe a slight chance, maybe, right? Because every time as a client, or I will come in, of course, is in your case is DHCP assign you a random IP address. That IP address needs to be within that local area network. Make sense? Similar case for the client. That's the situation. You post to your client. Client IP address is what? Could be temporary IP address. Make sense? That's some of the things about in your case. Just quickly talk about the client and the server situation. Okay. See, some summary here. Server needs to start first, be ready, right? And the client is start when you need it. You start, but you need to initiate this process. So server needs just ready and passively waiting. And the client is when I need it, you need to access certain doing browsing. You start sending the request. Just to quickly explain those kind of process, client server. For the peer-to-peer, you guys already know for the peer-to-peer, I only highlight this part. So as you apply the terms peer-to-peer, right? So for the peer-to-peer, one of the benefit is what? Scalability. Because everybody is what? Helping everybody. For client server, everybody is asking for the service from the server side. And the server typically is the bottleneck. Make sense, guys? That's some of the I want to emphasize just a little bit. And this is some kind of example. That's a BitTorrent. And some kind of auto-simulate is a Chinese application. And even the Skype also is a peer-to-peer. That's some of the example using P2P and the network architecture. Okay. And in many situations, think about if I provided some service, who uses Skype? It used to be popular.
Used to.
Even for those applications, think about we want the scalability, right? It's mainly based on the peer-to-peer. But at the same time, you need to think about if I have provided this application, I need to manage this application. Make sense? From the client server, management is relatively straightforward because it's already server providing the service. Make sense? If it's peer-to-peer, you could provide service, you could ask for the service. And you can think about the management would be a little bit tricky. Make sense? Then if you're providing this service, sometimes you also, besides those kind of distributed service, which is peer-to-peer, sometimes you also need a little bit of centralized flavor in there, just totally for the management device. Make sense? Otherwise, it's too distributed. Who is responsible for this? Okay, that's basically I put a hybrid kind of. You need some kind of hybrid flavor. You need certain kind of centralized management concept in there. But the majority of those kind of functionality is provided by peer-to-peer. It's kind of distributed. Make sense? That's basically give you a little bit. But for the peer-to-peer, the advantage is what? Scalability, right? There's no obvious bottleneck. Then the challenge is because everybody's helping everybody. Could have security issue, have a reliability issue, performance issue. Makes sense. That's coming. That's some kind of challenge associated with it because it's a distributed kind of activity. Okay. Then, guys, we talk about. Remember, the keyword host to host should be network layer, right? And the process to process, mostly application or transport to transport layer. Remember, each different application is associated with each different process. Okay, that's basically process. In that case, if you are client server architecture, you have a client process, server has a server process, right? It's a process to process communication in there. This is talking about the socket. Then later on, remember later on, we'll move on next later on section. I want you to pay a little bit attention in the identifier part. How to be specified, which kind of a socket, how to identify each different socket. Socket is basically the gate between application and transport layer. Make sense? Just this later section, we'll talk a little bit more regarding to the identifier part. Okay. And for this part, guys, what transport service does the app need? Depends on different application. Some applications need integrity. Basically, it's another word is reliability, right? And some kind of application they care about. They have a throughput requirement. Right? If you watch a movie, if the throughput is kind of, think about it, if you are nowhere. If you are nowhere, for example, you are doing a ski trip, you're using your phone. Can you watch a movie there? Typically not, right? Makes sense? Because the available bandwidth is not wide enough. Because you are typically using your cellular service. Makes sense? That's basically for the throughput part. For most multimedia application, they need to have certain kind of minimum bandwidth requirement in order to make those kind of applications possible. Then for some application, for example, when you are nowhere, you still can send an email, right? Right? For some application, we call it elastic application. Basically, the requirement to the throughput is not that high. Make sense? Yeah. If you're doing web browsing part, you can wait a little bit longer. Just be patient. Just the web page is still coming down. If you send an email, it's okay. But if I'm calling somebody using the internet, if the bandwidth is the throughput, the bandwidth is not wide enough, ask, hi, wait for 1 minute, no response. People are like, oh, it's not happening, right? Make sense? So in that case, you need to certain minimum throughput to support those applications. Okay, that's regarding to throughput. And the timing-wise, timing and the throughput is still different. For the timing part, for the phone, like the phone call has more like timing, both timing and the throughput, right? Make sense? If you, for example, I want you guys to think about the throughput and the timing requirement difference. Can you give me an example? They have the throughput requirement, but the timing part, they are not that strict. Anybody want to provide the example? They need the throughput requirement, but the timing-wise, they are not that strict. Video stream. Which case of the video stream?
Not live.
Exactly. I like this. For example, you're like a Super Bowl. Yesterday you watch, you still care about time is still important, right? But if you are watching some kind of a YouTube video, the content's already there, right? As long as you can watch it smoothly, regarding the delay, how long you can hear, it's fine, right? But if your game is enthusiastic, if you're playing multi-people game, what do you think? Do you care about the timing?
Yes.
Makes sense? That's basically, I just want you guys to think about, because now we are talking about different application, right? Then you need to know the application requirement towards transport layer. Make sense? Okay. Security-wise, remember that guy that's a server guy. When they created TCP/IP, at that time everybody's honest, joking. At that time they didn't think about the security part, and most of the security is later on patched out. Okay, that's initially when they created TCP/IP, the security is still not in their mind yet. That's when the first design they didn't put up. So that's basically the original TCP. They cannot provide the security guarantee. Make sense? Okay. For this one, guys, I want you guys later on this slide is in your book, and I want you guys to pay a little bit attention regarding to different applications, the different requirements. Make sense? We kind of already talked about it, but I just want you guys to think a little bit. And this one, everybody is clear, right? Then remember the RFC. If you are interested, you always can look for corresponding RFC for detailed, requirement there. Okay. And in this slide, guys, for the file transfer and the download, for example, FTP or email attachment or FTP. So it needs to be based on what? TCP.
Because it needs to be reliable.
Thank you. And for the email protocol is SMTP, and it also have to base on what?
Reliability.
Because for the email, I might send you some important information. Like today's class is start at actually nobody noticed it. The class start at 4:30, right? During some time it changed to start at 11 something. Who noticed? Nobody. Because Melissa keep talking to me, then later I have to ask them to change back. For the email, if I send you something like your name, some information, we still care about the integrity. That's why it has to be someone TCP. And for the web, for the HTTP, right, web browsing, see, for this one, we put the protocol version in there. 1.1 is based on TCP. And what's the current HTTP protocol? How about the HTTP 2? HTTP 3 is still based on TCP. So remember, it's subject to change. Makes sense? So for HTTP web browsing, of course they care about the data integrity, right? They do care. So for HTTP 1.1, currently still popular, which is based on the TCP. Then, guys, so far for transport layer, we have TCP and UDP. What you have learned is what? UDP is what? Simple, right?
Yes.
And unreliable.
Yes.
And the TCP is reliable, right? Remember the quiz you did. And the TCP can provide what?
More services.
More services can provide at least reliable, right?
Yeah.
Then remember the multiple choice also has a flow control, congestion control, right?
Yeah.
And the UDP is the best effort, which is just the setup about the network layer. Make sense? Remember, no free lunch, right? TCP and the UDP ask you pro and cons. For TCP, of course, the advantage of TCP is reliable, right? Later on, we will explain. Who knows flow control? Later will remind me explain flow and congestion control. And UDP. Then think about what's the benefit of UDP.
Fast.
Because it's simple, right? We call it's a SIM protocol. That means its associated cost is also less. Make sense? Not like TCP. In order to achieve because both transport layer, both TCP and UDP, which are sit about what? Network layer. Network layer is what? Best effort. Basically, remember, internet is based on packet switching. Remember, it's best effort. We cannot guarantee. But the TCP still they have the same foundation, same base. Make sense? And the UDP doesn't do much. Just add a basic functionality, add the corresponding port number there. Make sense? But it didn't provide much. It's very, very simple. TCP, in order to provide those kind of reliability guarantee, they have to, that's next chapter, they have to add lots of stuff. Make sense? That's including flow, congestion. In that case, it will be what? Not that efficient. That makes the UDP, the advantage is very efficient. Make sense?
Yeah.
So that's basically, I want you guys, nothing is settled. When we talk about the HTTP, right? Guys, HTTP is based on what?
TCP.
Really? Really? HTTP is based on what?
Client to server.
Later I will get your phone back, okay? Listen, so HTTP, whether it's based on TCP or not necessary. If HTTP is 1.1, will be TCP based.
Okay.
My point is, still we are talking about it's kind of an evolving concept. If we move on to HTTP 2 and 3, that is still TCP based, not necessary. Because remember, people are kind of greedy. We like the HTTP need the reliability, right? At the same time, they don't like TCP as well. Inefficient feature. They want UDP to be efficient. Makes sense?
Yeah.
That's later on. The reason HTTP is based on UDP. Makes sense? Because they want to be efficient, but reliability is still important. They need to add the reliability, the functionality in design in the new protocol in the application layer. My point here is nothing is kind of strict. You need to depends on the situation. It's kind of keep changing. Makes sense?
Okay.
I cannot say HTTP is based on not necessarily. We need to keep the version number in there. Got it, right?
Yeah.
That's basically. But many of the, as long as you understand for those applications, the requirements, how to implement those is going to change. Got it? Then later on, talk about streaming audio and video. And interactive games. For those applications, based on your requirement, based on what we so far learned, it should be based on what? Think about the streaming application, right? Most things, multimedia, we don't care about that much integrity, reliability, right? It should be based on UDP because it's more efficient, right? But if you check the right side column, not necessary. Why? So you guys make sense. It's not that straightforward. The reason is later on, because we need to move on to the next chapter, the TCP part, right? TCP, remember, they have a flow control and a congestion control. So what is flow control? Nobody knows yet? Anybody? Flow control?
The rate at which the sending device should send on the transmitting channel.
Flow control basically is an end-to-end concept. Okay. For example, you still can play your phone. Joking. Okay. I'm sending you something. I'm using a supercomputer. I'm trying to send you something. You're using your phone to get my message. Okay. If that's the case, I'm just keep sending you, keep pushing you. What will happen? Definitely overwhelm you, right? Makes sense. Basically, because your phone have limited resources, have limited buffer. Makes sense?
Yeah.
If I keep pushing your stuff, your phone just cannot handle those messages. So what is flow control? Because the sender will not overwhelm the receiver. Makes sense? In that case, how do we get the flow control? So in many cases, that's why remember, UDP doesn't provide the flow control and the congestion control, right?
Mm-hmm.
How do we get the flow control? TCP doesn't care, right? So in order for sender will not overwhelm the receiver, what will happen? we need to provide flow control. In that case, we need to constantly get the feedback from the receiver. Receiver need to let you know what's the current situation. Makes sense? Like the receiver, the buffer is already full. They need to somehow, later on, that's for some details in how to design TCP. They need to send out some kind of feedback. This way, if I know you're kind of already overwhelmed, so I will slow down. Make sense? But UDP doesn't do that. UDP, if I need to send you a sentence, just send you a sentence. I don't care, because UDP is kind of very simple protocol, right? That's flow control. End-to-end concept. Sender will not overwhelm the receiver. Congestion control. So congestion control is another concept, but the concept is slightly different with flow control. Congestion control is a network-wide concept. Okay, for example, if the network is already congested, we still push more stuff to the network, the congestion will get worse. Make sense?
Yeah.
If the network congestion gets worse, think about it. 290 is already very congested. If something happens, then it will get worse. Nobody's going nowhere. Make sense?
Yeah.
If nobody goes nowhere, that means the buffer will be full. The delay will be too long. The packet will be get dropped. Then it will get even worse. Make sense?
Yeah.
If that's the situation, you still keep pushing the packet to the network. The network will be
Overall.
but probably fast. Right? So in that case, what should we do? Everybody should behave like a gentleman. We should have a congestion control, right? We should slow down. We just do not push too much stuff to the network, right? Let it down. That's basic for TCP. They have a congestion control. Makes sense? But the problem is, I'm trying to explain even for the streaming wise, although UDP is best for that, why there's still most of traffic is still based on the TCP. Okay? Although UDP doesn't provide congestion control, right? But if you think about it, the majority of the user is TCP based, and the network is congested, everybody's backing off. But I'm using the UDP, right? I don't have congestion control. What will happen? The UDP-based application, they can still push the stuff to the network, right? Are you happy? It's not fair, right? Makes sense? That's basically, even though for the streaming application, UDP will be the most efficient one. But in certain, because it doesn't provide congestion control. So sometimes consider, the fairness. Some of the firewall, some kind of routers, they still have those kind of measures. They do not want the UDP traffic. Makes sense? That's why many of even though streaming based on UDP definitely will find, because they don't care about the integrity that much. Makes sense? But still, majority of the traffic is still based on the TCP, because TCP implement congestion control. Because everybody still need to play fair, right? Make sense, guys?
Yeah.
Got it, right? So my point here is I want you to think about on the right-hand side and left-hand side. It's not like that straightforward. So makes sense, right?
Okay.
But you kind of understand for the TCP what they can provide and UDP what they can provide. That's basically. Then for the security, we already mentioned, it's kind of hashed up later on. Okay, original TCP didn't provide security feature. So if I ask you this question, guys, what's the time? I still have a couple minutes, right?
Yeah.
So if I ask you,
Want to go home?
which could be provided by internet transport protocols, somebody could see from the prelim, right? Yeah. What do you guys answer? Question is, which could be provided by internet transport, basically transport layer protocols, right? You guys will pick
One.
reliable interest. Basically, for transport layer, TCP could provide one. That's it, right? They cannot provide throughput guarantee, cannot have the timing, cannot have the system reasons. Security is limited. Got it, right? If it's UDP, nine, right?
Yeah.
sense? They can still, majority of the time, remember they are playing the probability, they are still okay, but just we just cannot have the strong word like guarantee. Make sense? Yeah. Okay. And then I will kind of stop here. Okay. So we talked about the network application structure, right? I want you to think next time we'll start with HTTP as an example. But I kind of want you to think about regarding the difference of the network application and the application layer protocol. Just think about it. This looks similar, but still different. Make sense? Think about those. Like when we talk about network application, web browsing is application, right? Talk about the protocol. Possible when we talk about web browsing, mostly in your mind is HTTP, right? But right, could be right. When we talk about the email, it's an application, right? But the associated protocol, at least the SMTP, right? Maybe others, makes sense, right? So basically, there's an application. It will cover a little bit more. Protocol is only part of those type of services. Makes sense? Protocol, think about it. It's still similar. That's it, guys. It's possible. If you can watch it, bring the questions to here. That would be perfect.